Hi everyone, thanks for joining me here today. We're going to talk about how we can hack our vacation using data. So we've gone over a lot of really important data and AI topics here today. Now we're going to get a little fun. How can we use that data and those numbers to have powerful and meaningful results, but also to have a little fun with it? So first I want to introduce myself. I'm Becky Gandillon. I'm currently the practice lead for data and analytics at Centric Consulting here in beautiful St. Louis, Missouri, where last week it was negative temperatures and this week we're in the 60s, so you never know what you're going to get. My background in education is actually all in biomedical engineering. I spent the first decade of my career at the Department of Veterans Affairs doing that sort of work, and then I made the switch over to the dark side, data and analytics, and now I specialize in data strategy and road mapping. I've dabbled in a lot of things, including architecture, data science, visualization, etc. Now I help people sort of strategize how to best make use of their data and how to get from where they are today to that sort of ideal future state. But also, I happen to be the mom of 2 young kids who is a lifelong Disney fan. My parents took me to Disney World many, many times as I was growing up, and I'm a vacation super planner. I plan out all my vacations in spreadsheets. I typically have, 3 or 4 vacations planned in advance at once. I am a very crazy blogger type with over 100 posts in the past year, and I have a YouTube series where I explain a bunch of Disney data things, and that's gotten pretty popular by itself. So in this sort of realm, I specialize in crowd and touring analytics and essentially how to optimize your vacation using data. And that's what we're going to talk about today, is how we can use this data to be more fun. Now, when I structure sort of problem solving, engineer by background, right, I need to start with a set of goals, then I need to collect data to help me figure out how to achieve those goals. So, for example, if I'm going to go on a vacation to Disney World, my goals would be to avoid crowds, to save as much money as I can, because dang, it's expensive, and ideally to enjoy my vacation, because even if I avoid crowds and save money, if it's not enjoyable, then what am I doing with my vacation? Today we're really going to focus on this first one. How can I use data to avoid the crowds? If we had more time, I'd go over the second two as well, because I think you can address with those with data as well. But let's really focus in on how can we use data science, specifically to avoid the crowds on an example Disney World vacation. So what's even the problem here? Like, why do I even need to address that? Why can't I just see people and avoid them? It's because the problem is complex. Let's say my family wants to spend one day in Magic Kingdom, and I just want to know where the people are going to be, when, and how to avoid them. Well, I have to take into consideration the park's capacity, which changes on a daily basis, especially post-pandemic. I need to figure out, regardless of capacity, how many people are actually going to be there that day. I'm going to assume it doesn't reach capacity every single day. And then hourly, are those people all arriving right when the park opens and staying all day? Do they just come for the middle of the day? What does that look like? Ticket cost can impact how many people are coming at any time, and that varies, and so trying to figure that part out. Operating hours, longer days, does that mean more people, or does it spread the same number of people out? How might that impact things? Which of the 29 to 39 attractions that are open on any given day are people going to go to, and when? Where are they going to be eating? When are they going to be eating at between these 31 and 33 dining locations that they have to choose from? Are they going to be spending a lot of time shopping, or can my kids go get their souvenirs without being too overwhelmed at the 13 different shopping locations? Do they have different dining preferences? Are there different dining quality that I need to be concerned about? How popular is each attraction? I can't just split people evenly between the 39 different attractions, so I need to figure out where they're going. Dining popularity, which is oddly pretty different than quality. Thanks, influencers that get people to go to different places. Upsell opportunities, do I need to take advantage of those to try to avoid crowds? Are other people going to take advantage of them? And on top of all of that, I have to make park reservations for which parks I want to go to on which days. Note I said which parks, because this is only one day in the Magic Kingdom, and in reality, if I'm flying my family all the way to Disney World, I'm probably going to want to visit all 4 parks, and that multiplies this problem almost exponentially. There are also 2-ish water parks. It's winter, and one still hasn't quite fully recovered from the pandemic, but we'll call it 2-ish. One shopping district called Disney Springs, where you can spend a whole day partying with your hard-earned money. A Galactic Star Cruiser, which is a cruise ship on land that lets you pretend you're in space and role play for a whole 2 to 3 days. Ridiculously expensive, but it does impact some crowd behavior. And 34 different resorts that people are going to also be wanting to spend their time in. How in the world do I figure out where all these people are going to be, how many of them there will be, and what their touring behavior is going to look like? Yikes. So now I know the problem. I need to start gathering the data to figure out what that problem is going to look like in the real world. If we were together in person live, I'd quiz you and make you come up with these on your own, but yay, you get to be virtual and I get to tell you all the answers. Here are things that I would start pulling in order to answer my own questions. School calendars, #1 predictor of crowds in Disney World, how many schools are out. Spring break, Christmas, summer, Thanksgiving. If kids aren't in school, you can bet their families are going to be taking them to Disney World. Economic data, if the economy takes a downturn, people can't afford to go to Disney World. It is an expensive vacation. Travel agent trends, and so how are things going? Are more people booking? Are people canceling? Prior years of actual results. This is a pretty reliable predictor of future years, except when you get into that pandemic era and everything throws itself off. Weather trends, hurricane coming, parks are going to be pretty empty. If it's nice and warm and not 100 degrees outside, then those parks are going to be crowded. Operational info, like events that draw crowds in or refurbishments that takes capacity out. And then on the right side is more sort of self-generated or gathered data, scraping of posted wait times. Disney does have their own app that shows you updated posted wait times for every attraction every 5 minutes. You can really easily get access to that. You can have your own app that helps people submit their own actual wait times, which are different than those posted wait times. You can have an in-park testing team who's going and actually recording waits and figuring out the best touring strategies. User surveys after they go visit to talk about what went well, what didn't, what was highly satisfactory, what wasn't. Cost info that you can scrape. Available park reservations, available dining reservations, available resort reservations. If all of those shrink, then you're probably going to have more crowds. So we can start gathering all of this data and try to piece together what that's going to mean. And so how do we do that in order to avoid these crowds? As an example, this picture is from when the parks were at less than half capacity after the parks reopened thanks to the pandemic. And this is before Magic Kingdom even opened for the day. So you've got maybe half as many people maximum as can fit in this park. And the park's not even open, so all these people have gotten here nice and early, didn't sleep in. So how do I avoid this mess? Because I don't want to stand in that crowd, and probably neither do you. The answer actually is, I'm not going to say simple, but the tech stack required to figure out this problem isn't that difficult. You can scrape all of this data, store it in AWS, use some fancy Python, do some TreeNet stuff, and you'll get your answers pretty easily. And the way I'm going to talk through this, I want to talk more about the results and how we make this meaningful and usable than the actual algorithms themselves. But I'm also going to be presenting it in a slightly backwards way. We really create models for each attraction for every minute of the day and then aggregate those to a full park level. But I'm going to start at the park level and work our way down because that makes some more intuitive sense. So once we put all of that through our algorithms, then we pop out sort of these crowd predictions. And so if you happen to be really inspired by my talk today, you might decide to go to Disney World tomorrow. And if you did, here's what you could expect. We could see some pretty average crowds. We can see that 1 would be the lowest crowds, 10 would be the highest. And we're getting a bunch of sort of 4, 5, 6, 7. I get some information about when the parks are open. I get some information about any special events and about how much a one-day ticket is going to cost me. So this gives me a lot of different information, which is really, really helpful. But what does this actually mean? What's the underlying data behind this? So we're going to zoom in to the Magic Kingdom, and I talked about these levels 1 through 10 and that 4, 5, 6 area being the middle. We can see some attractions here at the Magic Kingdom, as well as their average posted wait time during the middle of the day, sort of peak visiting hours, at each of these crowd levels. Now what we do is we predict a bunch of days across the year and sort of force things onto a bell curve. So you're only going to have a few level 1 days, a very few level 10 days. A lot of them are going to end up in the middle, and that impacts sort of the feel of what you experience when you're in the park. Bonus, it also looks like a roller coaster. Yay, we can have a little bit of fun in this presentation. So what does this look like? I'm cheating a little bit because I'm somewhat predicting the past, but I wanted some good example data to show you the differences in what this feels like. That week around Labor Day every year, either immediately before or after, is the least crowded time of year in the parks, reliably, every year. You want to avoid crowds, just go then, and you really don't need to pay attention to any of the rest of this data. But a lot of people can't, because a lot of people have kids in school, and they've just started school, and you don't want to take them immediately back out. So we can see here that these are all crowd level 1s. What does that mean at the Magic Kingdom? That means I'll have about an hour posted wait time for Seven Dwarfs Mine Train at the highest, most crowded part of the day, 45 minutes at Peter Pan's flight, maybe 30 minutes at Winnie the Pooh. These already might seem high to you, and you can avoid even these waits if you plan further, and we'll talk about how. But it's nothing compared to if you choose to go, say, during the week of Thanksgiving instead. And here we see what a crowd level 9 at Magic Kingdom might look like. Instead of waiting an hour for Seven Dwarfs Mine Train, I'm waiting up to 3 hours. Instead of waiting 45 minutes for Peter Pan's flight, which, by the way, is a 1-minute ride in a flying pirate ship, I would wait 2 hours for that ride, up to 3 hours for Space Mountain, and quickly my day is gone. So that's more what a crowd level 9 looks like. But I can also see, if I use this crowd calendar, I can sort of tweak my 4-ish days in the park and avoid some of the waits. I can get to an 8 at Magic Kingdom and an 8 at Hollywood Studios, and I can play with that a little bit. And so if I'm forced to visit this 1 week of the year, at least I can try to avoid as much of the crowds as possible, optimize within my own constraints. But we can dig even a little deeper than this. I said the algorithms, the results underlying this crowd calendar, are for every attraction for every minute of the day, which is totally true. And as an example of that, I have crowd level 10-day behavior up on the top and crowd level 1 day on the bottom. And 2 very different attractions, Seven Dwarfs Mine Train, which is the headliner at Magic Kingdom right now, and Dumbo the Flying Elephant, which, while a classic, doesn't exactly draw the same crowds. So I can see on a crowd level 10 day, the very most crowded days of the year, Seven Dwarfs Mine Train immediately gets a high wait time. It might have a little dip around 10:30 there, but then it goes up even higher. Things get really crazy. They don't come down until people get fed up and leave the park later in the evening. Dumbo behaves somewhat similarly, but it doesn't immediately spike like Seven Dwarfs Mine Train does. It takes it a lot longer, because it takes people longer to figure out that they can't just ride headliners all day if they don't want to wait 3 hours in line, and so they go places like Dumbo. But if I go down to crowd level 1, this behavior looks a lot different. On a crowd level 1 day, a bunch of people are still rushing to Seven Dwarfs Mine Train because they know in their heads intuitively that it's going to get more crowded later in the day. The problem is, on a crowd level 1 day, there aren't those more people to keep coming into the park and keep crowding into Seven Dwarfs Mine Train. So it actually behooves you to wait a little bit, because everyone's going to rush there because they're conditioned to do that. And if you go in the middle of the day on a crowd level 1 day, you might actually wait less. We see something similar for Dumbo on a much smaller scale, but it's not just crowd levels that impact this, it's time of year, it's weather, etc., etc., etc. So it gets really complex. So how do we make this work for real humans? I can't memorize these graphs for the 39 attractions in Magic Kingdom for every day of my visit, plus the other parks. So we have to make it in such a way that people can use it that makes sense to them. They don't care about the algorithms. They don't care about the graphs like you and I do because we're data people. They care about where I should go next and what's my plan for the day going to be. So we can create essentially a web app that skins all of these algorithms to tell them an optimized day. So for example, let's say you're super inspired, you decide to go to Magic Kingdom tomorrow. Then you can tell it which attractions you would like to visit. So normally I do this sort of live and we'd see the magic happen, but it's a recording, so we're going to try to just make sure that we understand what's going on here. I can select which attractions I want to go on. I'm going to avoid Astro Orbiter and the Barnstormer, but I do want to ride Big Thunder Mountain. I'm going to ride twice on Buzz Lightyear because I'm super competitive. I want to see the Country Bear Jamboree. And this goes on and on as we go down the list. So I can make this totally customized to what I want to do that day. I can also choose shows and parades. I can do child swap if I have someone that's too short to ride, etc. Once I do that, I can either evaluate my plan. That will go through step by step in the order I put it in and tell me how long I can expect to wait. Or I can let it optimize for me, which is the real data magic that happens. When I do that, it's going to look at those predicted graphs for every attraction that I want to do for the hours that I say I'm going to do them. And it spits out this handy dandy plan for my day. So I told it I wanted to do Buzz Lightyear twice. It puts both of those very first thing in the day, then it lets me go to Space Mountain, then I go to People Mover, and I progress throughout my day that way. And it has totally minimized that wait time based on all of the information I've given it up to that point. Whew, that was a lot. And there are some toggles on this in the real live version, so I can tell it if I walk faster or if I walk slower, for example, if I have a stroller. Or I can tell it I don't want it to just minimize weight, I want it to minimize a combination of weight and walking, aka I don't want to have to cross the park 87 times to save 3 minutes to sort of balance those out. So I give it a little bit of parameterization so that the users themselves can have an optimized plan for them and not just for the average human. And then in the end, it's not helpful if I print out this paper and go to the park and I get to Space Mountain in my third step and it's down. I need to know real time what's happening. And I need to be able to re-optimize that plan regularly. And so being able to put it on their phone, something they have with them in the park, that scrapes those wait times every 5 minutes and can re-optimize and sort of be flexible on the fly, that's really important. Bonus, it can tell them actual expected weights instead of what's posted, since those are different, and it can help them give me more data by timing their weights real time in the park. Excuse me. So we went through all of that really quickly. I want to thank you for paying close attention, and I really hope that it helps you understand how data can be used for really important things, but it can also be used for a lot of fun as well. Thank you.